So 2 years on, we're still here with the Ramin 3 Plus. In case you're not familiar with this machine, this is a fully rigid mountain bike with plus size wheels. So we've got 27.5 inch plus size, that means a 3-inch tyre on the front, 2.8 inch tyre on the back. It's got a 1x10 drive system, and it's a fairly respectably specified machine. We've got a Shimano group set, that's the Derailleur 615 drive train. I haven't changed much on this bike in the last 2 years, with the notable exception of the saddle and the seat post. I've put a suspension seat post on here, which has made a great difference. This is an SR Suntour NCX 12, I think it's called, and it really smooths out the ride. Gone for a Infinity saddle, which is extraordinarily expensive, but certainly the best saddle that I've tried to date. One downside of that is, if you're going to buy one, it comes with 5mm rails, which means it doesn't fit any of my mountain bike seat posts without shimming it. So I've got beer can shims in there. Works okay, it's just a bit of a pain. So those are the only modifications I've made since I made my previous videos about this bike. But changes in the air, we're going to replace the drivetrain now. Now why I'm going to do that? Well, if you watched my earlier videos, you will recall that I replaced the front chain wheel already. Now that was to give me a better compromise in the gearing. This bike comes with well, in my estimation, very low gearing as stock. So that's with a 32 tooth chainring on the front and a 11 to 36 on the back. Now I found that too low across the board, so I replaced it with 36 on the front. That gave me a more respectable spread. But lately I've been riding one of my other bikes, that's the Boardman full suspension, and that has a 2x10 setup, and I was reminded really how much more satisfactory that gear range is. So I thought about what I could do to modify this. The first thought was to just put a derailleur on the front. Seemed simple enough. Now it turns out there's lots of reasons why that isn't as straightforward as you might imagine, and indeed to do that you need matched components on the front and the back. So to cut a long story short, to do that justice, we're probably going to have to replace the whole drive system. So that's the chainring, possibly even the cranks, the rear cassette, the derailleur. The other thing that became very obvious as I was researching this is that, you know, the front derailleur is pretty much dying out. You will notice over the last few years, certainly since I've been mountain biking, we've gone down from triple chain rings. In fact, I've got a triple chain ring system on my Trek. I've got a double chain ring system on my Boardman and single on this one. The trend is definitely towards 1x drive trains across the board. So that's where my research took me. And you know, once you start looking into this, it's fairly complicated, and that's what I'm going to be laying out in this video really. Now, you know, if you're an expert bike mechanic or something, none of this is going to be new to you. It's probably going to be fairly laughable, but it's not aimed at you. This is aimed at people like me who are trying to figure things out as they go, learning about the bike and tinkering. And of course the most important thing to keep in mind when I was doing my research was the numbers. And let me just consult my little reference here. In top gear on the Boardman, we've got 42 teeth on the front, 11 on the back. Now if you think about that in terms of a ratio, that's a ratio of about 3.8 to 1. That's the ratio of the front sprocket to the rear sprocket in top gear. And what that means in everyday terms is every time you turn the pedals 1 revolution, you're turning the rear wheel almost 4 revolutions. So you're gearing, you're overdriving, if you like, the wheel. Conversely, in bottom gear we've got 27 teeth on the front and 32 on the back, and that's a ratio of 0.8 to 1. So we're no longer overdriving, and we have to spin the pedals more than once for the rear wheel to make 1 revolution. And that translates to, you know, those numbers are very carefully thought out in engineering terms to give us a useful top speed when we're in the highest gear, and very usable climbing performance when we're in bottom gear. And of course the spread of the gears in between is chosen I mean, you can vary that by buying different combinations of chain wheels and different cassettes, but that's fairly satisfactory. Now, so keeping in mind those numbers, the highest gear we've got 3.8 ratio, lowest gear 0.8. Just comparing directly with the Pinnacle, the highest gear is, now I'll say a little bit more about this in a minute, but 3.6, which is comparable to 3.8, a little bit slower if you like, potentially, and the lowest gear is 1.1. Now that's still overdriving even in the lowest gear, and 1.1 is pretty high for a low gear, and what that does is it means we've really compromised on the climbing performance. And I should say something else, those numbers are not strictly correct in terms of the gear ratio. If I tell you the number of teeth, in high gear we've got a 36 tooth chainring on the front, in high gear we've got 11 on the back, in low gear we've got 36 on the back. Now looking at the low gear first, 36 to 36 is obviously a 1-to-1 ratio, but I cited that as 1.1. And the reason I've done that is to compare strictly between this bike's gear ratios and the Boardman's gear ratios is unfair, because the Boardman's got 26-inch wheels, this has got 27.5 plus, which essentially is the same as a 29er wheel. In fact, I've measured these at about 28 3/4 diameter. So what I've done is I've scaled up those ratios by 10%. So 1-to-1 scales up to 1.1-to-1. I hope you're following. And that allows me to compare directly with the Boardman. I mean, what I'm saying is a 29er essentially is, or 27.5 plus is roughly 10% higher geared just by virtue of the different size wheels than the 26er. So those numbers are not great. We're okay at the top end, which is why I went for that 36 tooth chain wheel originally, but we're kind of woefully inadequate at the bottom end. And you know, the only thing we can do about it with this current gear train is to swap different chain rings in and out on the front, and if we put the original chain ring back on, you know, we pick up a little bit, although again not very much, in the low end. So we want to get rid of that, we want to change that. And my research led me fairly rapidly to a new trend, which is the 12-by gear train. So I bought one. I should say I bought this before my research was complete, but my research is now complete, and I know what I'm doing somewhat better than I knew when I decided to invest in this system. So the system I've gone for is called SLX, it's Shimano again, and it's an SLX 7100. So I mean, it's all in boxes at the minute, so that's the derailleur. I've got, just looking there, I'm going to see what kind of a task this is I've taken on. Now I'm going to explain why that is, but before we do that, we're going to look at the payoff. And the payoff is we have a 12 sprocket cassette on the back, and it's nuts, absolutely crazy. That's just ridiculous. Yeah, there was a time when the bike drive train was characterised by big wheel on the front, little wheel on the back. We're going the opposite now. This goes from 10 teeth to 51 on the back. That is much bigger than the front chain wheel on my current system. So this SLX system comes with that crazy cassette, which I'm going to say more about in just a second. And on the front I've opted for 34 teeth, which is just slightly smaller than this one. You can get a 32 or a 30. Incidentally, this I've opted for the 10 to 51 on the rear. There is also an option for a 10 to 45. Now, so far so good, but the next thing I discovered was this rear cassette uses a hub mounting system which is relatively new. It's called spline, and it's a proprietary system invented by Shimano on, well, I mean, you might think that this would be compatible automatically. In fact, I did think that because I've got Shimano stuff on here already. But Shimano I mean, it's worth saying that this SLX system, we've crossed a dividing line really between the top end of, I suppose, enthusiast equipment and the bottom end of professional equipment. And on their pro system, Shimano's invented this new system called Microspline, which is incompatible with their old system, which is called HG or Hyperglide. And what that means is that I've got another problem, because I've got a Hyperglide hub on this bike and this cassette won't fit onto it. So the next piece of the jigsaw is I can't use this current wheel. So my solution to that was to go shopping for a new hub. So here we have a Shimano Microspline compatible rear hub. This is an FH MT500. You've got to keep your wits about you. If you're doing your research on this stuff, you've got to do it meticulously. The variables that are important in selecting a hub are basically the dropout width, which is 135mm on this bike. So that checks out. You've got the skewer, this is a quick release system, so you've got the skewer length, which is 170mm, that checks out with what I've got on here. I think you could probably just buy it. The skewer is not it's not structural, so you could probably get different size skewers if you needed to, but the axle has to match as well. This is a 9mm axle on this hub, which is what I've got on. I'm not sure I've checked that actually, but I'm pretty sure the axles match, but there are 12mm axles, and of course there are through axles as well, which is something we don't have on the rear on this bike. So that, obviously, to use this as is isn't going to be possible. So the first thing I thought I would do is get someone to dismantle this wheel and basically rebuild this rim onto that hub. What I've done instead is I've actually sourced these are WTB Scraper I-45 rims, and I've sourced another one brand new on eBay for £50, so that's coming in a couple of days, and I'm just going to get them to build that wheel onto the new hub. Then I'll have the old one. If I ever want to go back to this drivetrain, it'll be a fairly simple matter. But it doesn't stop there. This hub uses the centre lock disc rotor system, which is not the same as the system that this hub uses, which means I can't use the existing brake disc. I've had to buy a new rotor, which is a centre lock rotor, which is compatible with the new hub. That's the next part of the jigsaw. Now moving on, we've got the chain wheel on the front. Can't use these existing cranks because, again, different mounting system. Now this chain ring requires the Shimano Holotech 2 crank system, which is something I don't have on this bike, so we've had to buy cranks as well. So we've got these cranks are amazingly light actually. I think that's one of the benefits of Holotech. I mean, literally these cranks, although they look fairly chunky, they're not solid aluminium, they're hollow and they're really light. So that's a plus. The next part of the puzzle, there's a clue in the box with the cranks, which is this very hefty thing, which is not part of the crank system. It's a tool, and it's a bottom bracket installation tool. And of course that leads us on to the inevitability that the bottom bracket required to run the Holotech system is not compatible with the bottom bracket that's currently on this bike, which is a SRAM GXR bottom bracket. So I've also had to source a new bottom bracket, which is from memory the MT800. Again, you've got to be very careful that you buy the right dimensions as well as the right type. This is a 68mm, what is it? I can't remember now, but 68 to 73 is the acceptable range. So that's pretty much everything we need. The derailleur, obviously, which I've already alluded to. We've got a shifter which amplifier as well. So that's SLX specific shifter on the chain, of course. Can't reuse the chain. This is a 12. And one of the things about this system, once you see it set up and working, the variation in the chain line across this is fairly insane. That's got to be like 10 centimetres. The amount of sideways flex presumably is engineered to work acceptably well. So, what's this going to give us in terms of the numbers? Just reminding ourselves, the gold standard, if you like, the Boardman top end, we've got a ratio of 3.8. With the SLX 7100 system, we're going to get a ratio of 3.74, which is not far short of 3.8. It's higher than 3.6, which is what we've got currently. So that's okay. We're going to go up a little bit in our game on that. But where we're really going to score is at the low end. We're going to go, at the Boardman we have 0.8, 0.84 in fact on the low end. The SLX system we're going to have 0.74, so we're actually going to have a lower bottom gear than the Boardman. So that's going to give us what we want, exactly what we want. It's going to give us the same deal but with a single shifter, which in terms of convenience, slickness, relatively speaking ease of maintenance. We're probably going to, I should probably weigh all these parts as well, and then when I take off the old stuff, weigh those, and we're probably going to get a significant weight saving as well. So I think that's about all we need to say at the moment. So currently waiting for the new rim to arrive. Going to take that into the local bike shop next weekend, and they're going to make up that wheel for me. Hopefully they're going to install the cassette and the disc rotor as well. I don't have the tools for that. And then in another week or two's time I can install all the other bits and we'll see how it performs. Unless I've missed anything out and I'm left with something that doesn't function at all. Which, given that I'm a complete beginner at this, is quite possible. So we've got the new wheel back from the bike shop. That's been built up onto the same rim as we currently have on here, but with the new hub, the new cassette and the brake rotor. So we're pretty much ready to go putting all this together. Now I have to say the one thing that worried me right off the bat about this, if you compare the dimensions of this new setup with the current one, we've got the same width constraint, 135mm, same rotor spacing, the same hub spacing, I think. So the one thing that's got to give is the cassette, and the cassette essentially sits closer to the wheel than the original cassette. And if you actually look, the thing that really worried me about this is that outside, well, I suppose inside, the largest sprocket is actually just inside the diameter of the rim. So that gave me a little bit of a nagging feeling about whether this was going to work. And the worry that I had was that the chain running from the front chain wheel to the lowest gear, runs the risk of actually making contact with the tyre. But I'm happy to say nothing's certain until we get there. But of course we know all these dimensions. We know this is a 2.8 inch tyre. We can measure the position of that sprocket from the centre. We know the chain line is 51mm, that's the distance from the centre line to the front chain ring. What we need to calculate is the angle between that inside sprocket and the front chain wheel, and the angle between the inside sprocket and the outside edge of the tyre. And as long as there's a significant difference in the right sense, of course, then we should be good to go. And indeed I calculated those values, and the angle to the outside edge of the tyre is about 2.1 degrees, the angle to the chain wheel is about 3.5 degrees. and then if you use those figures in reverse, you can calculate that the clearance from the tyre should be about, well, 8 millimeters, give or take. Now I'm comfortable with that as a ballpark, back of the envelope calculation, and you know, that's kind of comparable with what we have now. To the inside, or to the centre of the chain, it's about maybe 8 or 9 millimeters. To the inside of the chain, it's maybe 6 millimeters. So we shouldn't worry too much. I'll just try and measure the relative thickness of that cassette. Actually, it's about the same. So maybe the space is actually smaller on that cassette, and there's nothing to worry about because the overall dimensions haven't changed. So nothing to worry about, and the clearance will probably be about the same as it is now. So that's it. We've just got to get this thing on the road, take everything off, put the new bits on. I think we'll start with the cranks and the bottom bracket. Not quite sure how to get the cranks off this. I think it's got a self-extracting crankshaft. Hopefully that's the case, otherwise we might need another tool. I think I've got everything I need apart from that. So that's the cranks and the bottom bracket done. That was a fairly easy job actually, for something I haven't done before. With the exception of there's some very high torques on the bottom bracket, and you have to be very careful that the drive side is a reverse thread, so to loosen it you go clockwise rather than anti-clockwise. So the old one was a SRAM GXP, and it takes this tool. This is from Bicut, Halfords in other words, and actually it's not very long in terms of, it's tightened up to 40 Newton meters, so with that length of lever it's kind of hard to undo it without hitting it with a hammer. So the bottom bracket I've replaced it with is the Shimano one. That has a different, it comes with the cranks come with a tool. It's the same kind of tool but a different size for the Shimano one, but actually if you have the SRAM tool, the Shimano tool allows you to use the SRAM tool as a spanner. Failing that, you can, as I did, use a 32mm open-ended spanner on that, or a socket if you've got one. I don't have a socket that big, so I wasn't able to use the torque wrench to torque that up. That's a bit of a downside. So what I did was, with this is quite a long spanner, so I just did it as tight as I possibly could by hand. I didn't want to go hitting it with a hammer or anything like that. So the BB was easy to get on, cranks easy to get on as well. You know, you can look up on YouTube or somewhere how to do that. The old crank was a self-extracting Truvative SRAM type, so that was very easy to get off. The new one is, I don't know what you call it, but it's the Holotech 2. So you basically have a one-piece crank shaft and drive side. The chainring goes on a sprocket, and then the non-drive side is held on by 2 pinch bolts, and you pre-tension it using this, well, there's a cap that you slide in, and then you do it up by hand with this little Shimano tool. Now this didn't come with the Crankset, which is a bit of an omission. I don't know why it didn't, given that the BB tool did, but I did have one because it comes with this Bicut SRAM tool. So we're done, we've got all the bits on, pretty much ready to ride now. Derailleur went on okay. I mean, it's easy enough to put on, single bolt, but it's a very complicated mechanism. I learned a lot about derailleurs in the setting up of this. A bunch of things you've got to be aware of. You should think about, if you've ever had a spill or knocked the rear end, you should probably replace the derailleur hanger before you put on a new derailleur. It's very important that that's aligned precisely, and you need a special tool to check the alignment, so it's worth buying a new one. Probably about 10 to 20 quid to buy one. Now this is a fairly new bike, I've not dropped this or done anything untoward, so I just left the hanger as it is. Then, as I say, to single bolt to mount. It's very important, by the way, to make sure you've got the manual for the derailleur, the precise derailleur that you have, because the setup is going to vary depending on all sorts of things. And there's basically, I think, but 4 variables that you need to set up. So we've got a limit screw for the inward movement towards the largest sprocket. That's to stop it derailing the chain off the large sprocket into the wheel. We've got an outward limit screw for this, preventing it derailing off the small sprocket onto the frame. That's fairly easy to set up. Then there's a end stop limit screw. Now I don't really know what the purpose of that is. I have to do some research on that. But it changes the home position of the derailleur, and it's very important to get the proper shifting action. And there's detailed instructions to set that up in your manual. And once I'd figured out, you know, where I was looking on there's reference marks and things stamped on the pieces of metal. And once you know what you're looking for, again, that's fairly straightforward to set up. So that's 3 variables. The 4th variable is just the precise tension on the cable, and you set that up. Again, there's a method to do it. What you basically do is you want to shift into somewhere in the middle of the range and fine tune the tension in the cable so that there's no rattling, that it drives in that gear without rubbing against any of the adjacent cogs. And you do that tension adjustment at the lever end, at the shifter end. So that's set up. The actual shifting action is programmed in. This is why everything needs to be matched to everything else. So you've got a shifter that's designed to work with this derailleur, and it's indexed precisely for 12 steps, and you can't adjust that. All you can do is fine tune the tension, but the indexing is, as far as I know, is completely fixed at the factory, and there should be nothing that needs adjusting. But it's only for this cassette and derailleur setup. I'm saying that there is an alternative cassette, which is this is a 10 to 51, there is a 10 to 45, which requires a different derailleur, but probably requires the same shifter, because presumably the indexing of the cogs is the same. It's just the throw of the derailleur that needs to be tweaked. What else can I tell you about this? Well, this is a much bigger derailleur than was on here before, and what's kind of interesting is that it's fully extended position, which is going to be in the lowest gear. It comes down almost to about 8 centimetres shy of the wheel rim. Another thing to comment on in the same vein, I mentioned earlier I was worried about the chain clearance, and sure enough, when we're in the top gear, the bottom gear I won't do it, the chain clearance from the tyre is relatively small. I calculated it should be about 8mm. It eyeballs to about 5mm, which is comfortable. I don't see any problem with that. On the top run, on the bottom run, for some reason it's closer and it's almost touching. It's literally maybe 1 or 2mm at most away from the tyre. Now that doesn't seem quite right to me. That I would have thought plane of the chain ought to be completely vertical. Now maybe that's an adjustment issue, or it may be that there's just there's some quirky engineering built into this. As I said earlier, the chain line, if you look down on the chain, can be quite extreme in the sense that the front and the rear cogs can be offset. It may be that slight twist is a deliberate part of the design, who knows. But we're not touching the tyre, so that's okay. And again, when we're in the lowest gear, we're going to be going very slowly, so the chain's not going to be jumping around, and even if it does touch the tyre momentarily, which it won't because it's going to be under a lot of tension, shouldn't be a problem. I've also pretty much come to the conclusion that this drive system is fairly overspecified for this bike, and I say that, you will recall that it was actually very hard to source a hub for this frame that was going to be compatible with the SLX system, and I think the reason for that is that almost exclusively the microspline hubs come with boost axle spacing, so that's 148mm instead of 135, and generally a through axle rather than a quick release. Now that tells me that that system is really designed for much beefier bikes that are going to be taking a lot more of a hammering. And so really, you know, if you're going to embark on a project like this yourself, it's worth thinking twice if you've got a quick release 135mm axle. Not that it's not going to work, and it's you know, overspecified is no bad thing. This is going to be a great system, but you know, the scarcity of those hubs probably tells you all you need to know. The other thing is, you know, this thing with the chain, I guess, well, I'm busking here, but you know, again, we're out on the margins putting a plus size wheel on a 135mm axle with a 12-speed cassette. You know, we're probably running as close to the wire as we're going to get. So I'm guessing if I had a boost spaced hub, that would give us more space and hence more clearance from the tyre. So that's about all I can think of to say. What have I spent on this? Well, quite a lot. You know, I started off, as I said earlier, not quite realising how much of a complete revamp I was going to have to do. But you know, the basic SLX package, which is the cranks, the chain wheel, the chain, the shifter and the derailleur and the cassette, came in at £270. You know, it's a knockdown price. I don't know what it went for in its heyday. I had to buy the microspline hub, of course, that was £48. Then I bought the wheel rim, that was £90. Then of course the wheel build, that cost me £70 to get that done by the local bike shop. That was including the spokes. We've got black spokes on here. Brake rotor, because the brake rotor wasn't compatible from the old system. This is a centre lock rotor, that was £23, and the bottom bracket £19. So grand total 520. Now that's a lot of money. That's pretty much what I paid for my Trek Marlin all in. But don't forget that this system, if it's a good system, I can take it with me when I upgrade to another bike, or maybe even build a bike around that system, and I can just put all the old bits back onto this bike and sell it or use it if I need to. So, you know, look at this as an investment really, and an experiment. You know, it's interesting just to be able to tinker with this stuff, figure out how it works, and it's all a learning experience. So there you go, 1x10 to 1x12. Was it worth it? Well, time will tell.